All right. This packet, you will not finish this today, at least I don't think you will. Relatively self-explanatory. There are things, directions that you will need to do specifically on this page and then again on this page that I'll be checking for. So it might say to highlight or underline something or put a star by something. So you will need to kind of work on that as you go. So follow the directions. I would actually read this page over the first page and this third page over first. Just to kind of get a good idea, because in the end, yours is just going to have different stuff highlighted, yada, yada, yada. Different stars, different boxes, so make sure you're paying attention to the direcciones on the PowerPoint slide. So in my class's case, it'll probably be on the board. For Ms. Coleman students, it will check the agenda over to make sure you're doing it right. So page 1, there's going to be separate directions for. This page, looking at page 2, and again, I'm just going to go over this pretty briefly. I don't expect you guys to get finished with this today. If you do, congratulations. You rushed through your work, most likely. But just remember, today is only not 40 minutes, but it's 50 minutes time. And you guys haven't actually learned. You have your force pages, which you should have just watched the video on, then you share the force packet. Yeah. So looking at this, label the force in each picture as either push or pull, then describe whether the force is causing a change in speed or direction or both. Okay, so you're going to be looking at all those, and some of these might be a challenge, and that's completely okay. So I'm going to do the easiest one first because it's the easiest one. So we have a rocket taking off. First thing you need to do is either identify it as a push or a pull. So every blank box is going to have a push or a pull, and then you're going to say if it's a change in speed, direction, or both. Okay? So if I'm looking at this, I see the little space shuttle, which we no longer use, which is kind of crazy. The space shuttle is launching into space. Is that a push or a pull? Well, since gravity is pulling it back down to Earth, I'm going to say this is a push. As the rockets are pushing off, the rocket boosters are pushing off for the space shuttle and the rocket itself to go into space. This number 1 is a push. 2, is it a change? Here's my second thing I need to do, speed, direcciones, or both. Well, it's definitely going to be a change in speed. Direction, if it's going straight up, in theory, if the rocket is just taking it pretty much straight up, granted the Earth is still rotating, yada, 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 I'm just going to put speed for this one. Okay. In some cases, like this one, you clearly see it's going off. The direction of some of these is going to be changing, but for this one, that's all you got to push and speed. So you're going to get through that page. Remember, identify it's either push or pull, and then is it a change in speed, direction, or both. This page, the directions are already posted in the agenda online. Okay. This one, now I was kind of confused when I was looking at this. I'm like, what the heck? Each of these are separate kind of questions. So I know it says circle the best answer. You're not circling 1, 2, 3, or 4. You need to circle. There's 2 options for each question. So for number 1, it's asking you the forces shown above are pushing or pulling forces. You're either going to circle pushing or you're going to circle pulling, and that's your answer for number 1. Number 2, the forces shown above are working together or opposite forces. Make sure you look it over. This is 1,000 newtons, so in case you're like, oh, I can't read that. I'm telling you right now, it's 1,000 newtons, and this is 1,000 newtons. Okay, so there's no, I wasn't sure, Miss Penny, I can't read it because that number, yeah, I'm telling you what it is. Okay, this page. Again, you're doing the same thing. So the forces shown above are pushing or pulling. Are they going to circle pushing or are you going to circle pulling? Wow, it's so difficult. This is 100 newtons. This is 200 newtons. Okay? There you go. Finish that. Now this is where it gets kind of, it could be fun for you. It should be kind of easy, actually. It looks kind of confusing, but it's not. So it's a vector. Vector is a line with an arrow. Wow, that's really cool. It begins with a dot. Now, the only thing that is kind of confusing about this, I'll have to kind of give you some extra directions, because as I was doing this, I'm like, it's kind of confusing because some of them appear to kind of start. This one's perfectly at an intersection. Okay, so for this case, so just assume that it's kind of starting at a point. So for example, it says each square represents 1 newton. So if I'm looking at this is 1 newton right here. It has traveled 1 newton. Now it's traveled 2, 3, 4, and 5. Because notice the arrow does take it all the way to that little line. So each one of those, that's why it's saying this vector shows a 5n force to the right, because I see that it's moved 1, 2, 3, 4, 5. newtons to the right. Now, looking at these, you're going to notice that some of these are not at a perfect intersection. I just want you to assume that it is. So, for example, just assume that this little dot goes from right there. Okay, so you would do, here's 1 newton. And you don't have to draw the boxes. I'm simply doing this for visual. You can just count them. On my answer sheet, all I did was little notches. 3 and 4. Okay. Now, I know it goes over a little bit past that line, but for example, this one is going to be the force, when you're filling it out, it's 4 to the right. Okay, because as I'm looking at this, pretty self-explanatory, 1, 2, 3, I counted 4 boxes over. So for some of these, for example, like this one right here, it doesn't go all the way to the line, so I would count this as a half of 1. So this is going to be a decimal. And I did I think all but 2 of them I have pretty much as decimals. So I think number 1 and number 2 I have as, I guess, whole numbers. There's no decimals. But for 3 through 10, I have them as decimals. It doesn't seem to me to kind of matter. So if it's halfway, I would count this as halfway. So 10 is going to be however many, 1, 2, 3, 4, 5. 5.5 is what I would say for number 10. 5.5 newtons up. So that's how I kind of want you to do this. And again, just assume that it's starting at the closest block. So for this one, it's going to be right there. I understand it's not perfect, but it is what it is. So imagine the dots are always at an intersection, and decimals are fine. So you don't need to write this on your paper. I'm just putting it. Decimals are okay. Okay, so all but 2 will be decimals. Okay, so only numbers 1 and 2 will be whole numbers. Okay, looking at this, this is going to be drawing them. Okay, and I would start, if you know you're going to be drawing something to the right, I would start more on the left side. So, oh my gosh, the alarm's going off again. All right, this is something that was kind of confusing. This is 7 ends to the right. Here's what you're going to draw in this box. This is 5 ends to the left. This is 3 end downward, and then this is 10 end upwards. So you're just drawing them. It's really not that difficult. You're going to start at a certain point, and if you want to draw it over here on this side or over here going upward, it is what it is. Now these are vectors, or they're kind of showing 2 opposite forces. So this is going to be the resultant. So it says there's a 5 kilogram force to the right. So this is just going to be 5 ends, okay, going that direction. If you count it over, 1, 2, 3, 4, 5. And a 7 Newton force to the left. So 1, 2, 3, 4, 5, 6, 7. So in case you're wondering, how did they get those numbers? That's what we're looking at. 5 newtons. That's supposed to be an arrow. It sucked. Okay. And again, if you do not finish this packet today, it is not a big deal. It is not for homework tonight. You will have some time tomorrow, Friday's class to work, and I, however, do not expect to have the entire class. There's a 5G force to the right and a 7 N force to the left, just like we did the boxes in your notebook. If you have, obviously, 2 forces going opposite directions, and one is larger than the other, obviously they're both 5N, the resultant would be 0. But the resultant is going to be 2 N's to the left. So how they did it is, they did it the same point. So wherever yours is at, you're just going to take it 1 and 2, and that's your resultant. It's going to be 2 N's to the left. Why? Because 7 minus 5 is 2. And we know the 7 one is stronger, so it's going to be pulling to the left. So looking at the back page, okay, it gives you another example here. It says that there are 2 5N forces. So if I'm looking at this, here's my first vector right here, which goes 1, 2, 3, 4, 5. So here's my first one right here. Okay, and just where that one happens to stop, another one starts. So here's another 1, 2, 3, 4, 5. So we have 5 newtons there, 5 newtons here, and that resultant is going to be 10 newtons because it's all together. So when you draw your resultant, you start at the point, you draw it that way. So it's going to be 10 ends to the right. Okay, 10 ends to the right because they're combining. Okay, so this one is going to be kind of fun. You will draw the resultant. This one gives you a kind of clue or a sample, but you still need to fill it in. So the resultant is here. So whenever you start your resultants, let me look at my answer key. The resultant, let's see, I'll draw this one. Where do I want to draw this one at? Considering this, so this has to be, there's going to be a resultant that starts there. There's going to be a resultant that starts here. And again, just assume that these are actually at the intersection. There's a resultant that starts here. Here's number 6. There's going to be a resultant that starts here. Where is my number? Oh, I have that one. I have that one. Where's my resultant for number 4? Oh, okay, I know why. So for the most part, there are going to be, I think there's only one that has 3 forces. Number 5 is the only one that has 3 forces. Is there movement? So did it actually move something? Only one of these will be a no. So there's only one no out of all of these. Okay. Resultant, so what was the total? Was it 14 ends to the right? Was it 10 ends down? What was it? And for these, because all of these have 2 forces, there's only going to be one. And you can just abbreviate. So if there's one that's going down, down, up, you just put D, D, U. Okay. But yep, so the amount of force, so let's say number 1, 14 newtons, and to the right, because they're all going in the same direction. So resultant would be 14 newtons to the right, because I'm too lazy to write all that. Okay, but work through this. This is for an accuracy grade, so make sure that you're trying your best. Yada, yada, yada. All right.